Good job, you guys, for like paying attention to the front. Okay, so I really want to thank Francis Jeanson for showing up and giving us our first kind of guest lecture of BrainHack School. We also want to give a big thanks to the OBI Center for the Ontario Brain Institute Center for Analytics for actually sponsoring the school this year. So big thank you there. Uh, uh, let's see. So at the head, well, you're going to speak about what the OBI Center for Analytics does.
Yeah.
We've been working together with OBI for quite a bit, and you've been working with OBI for
on and off for a long time.
Okay.
Yeah.
Well, okay. Yeah. So Francis is here to tell us about neurodata from around the world, help us think about the data sets for our projects. After he speaks and after he takes questions, we also want to give a little bit of a disclaimer or a discussion or some guidelines about data sets for your projects. So some general rules about thinking about data access, about thinking about how long pre-processing would or would not take, because it happens every year that a lot of people get stuck. The month is over and they haven't figured out how to pre-process their data, and it's a problem. So unless you want a yes, we'll discuss that. And thinking about data access and ethics issues to sharing your data with a collaborative group. We'll come back to this, but I will pass the podium to Francis. Thank you,
Aaron. So I was told to speak in the microphone, which puts me all the way in this corner, but I guess this is fine and everybody can hear me, I hope. Thank you, Aaron. Thank you, Minarose, Ruchi, and all the organizers of the event. It's a really exciting event. They have, a lot of experience doing this, and I think it's been just tremendous over the years to see, I think, the community just really growing in the space of neuroanalytics and working together on solving new problems that we encounter in the brain space. I have a background in cognitive science, AI, computer science. Have done a lot of work in the industry, but also working in academia, and currently with the Ontario Brain Institute. We're a not-for-profit organization located here in, Toronto is the office, but we are really focused on supporting research in Ontario and even Canada-wide to really catalyze neuroscience research and really help the research environments make headway in really understanding the complexity of brain disorders. So really excited to work in this space. I'll give a bit of a background on OBI just so you folks are a little bit familiar with what we do and generally like the environments of supporting neuroscience research and what neuroscience research is all about. And part of it is around collecting data and making good use of that data, which I think you guys are going to learn a lot during this school, this BrainHack school. Yeah, so let's get started. I'll then get into like data sets that Aaron mentioned, which I hope will help maybe for some of you for your projects. But like Aaron mentioned, there's a lot to consider when using data, and not all of the data sets I'm going to share are necessarily appropriate, just based on like the time it might take to get access to them, the type of data that they might be, the complexity of those data. But there will be, I think, some nice, gold nuggets in there that you could probably make use of, and that could benefit your project. So let's get started. So quick introductions. The Ontario Brain Institute was founded in 2010 with the early vision of helping catalyze neuroscience research, primarily in Ontario, but also Canada-wide, and even internationally now. We're seeing an increasing number of collaborators around the world. There is a real opportunity in neuroscience, as we know, to better understand these brain disorders. It affects 1 in 3 people during their lifetime. And it's really something that we need to better understand is how these brain disorders work, what are their causes, can we mitigate them, can we potentially treat them? And the vision of the Ontario Brain Institute back then was really around leveraging the multimodal data that's underlying brain disorders and our health in general. And so we had the vision of establishing large research programs that we called integrated discovery programs that essentially span multiple sites that have lots of expertise across these different data types. So we have a large program in cerebral palsy called CPNet. We have a large program in epilepsy called EPLink. There's a large program in neurodevelopmental disorders called POND. There's a large program in neurodegeneration. It's actually sunsetted now called Andri. Depression is by Cambine. In concussion, we have a large program called Transcendent right now, looking at concussion. So major brain areas, these are multi-site research programs. So there are a lot of collaborators working together to investigate these disorders, and they collect data across the board. And the whole goal is to actually collect this data in a way that is, it's all about the same participant. So participant will actually get some neuroimaging data collected, some clinical assessments collected, genomic or other molecular type data collected. We also have common data elements. That means common elements that actually compare across not only the one study, but across the multiple studies. So they can start comparing and looking for maybe comorbid conditions, and even looking at patient outcomes. Like how does that affect the patients, and what are those outcome measures that we could measure? So this is a snapshot of the network with the 5 major programs right now that we have undergoing. And as you can see, this is a large network of hospitals and universities across Ontario, Canada, and a few outside. So quite large. And the big opportunity here is to not just support these research studies as you would a traditional sort of funding body, but to really create integrated discovery programs that look at not only collaborating with each other, but also collaborating with patient communities. So there's a big patient community engagement that's happening here. There's also a big component around working with industries. There may be startups developing new treatments or new detection algorithms that could help benefit this community, this community of patients and these research groups. So working with industry, there may be some pharmaceutical companies developing new treatments that could be really helpful for treating some of these conditions. So these programs each have a big emphasis on not just doing research, but also working with the communities, also working with industry partners. And all these studies collect data in a centralized repository that we call BrainCode. And so BrainCode is this platform at the Ontario Brain Institute that helps collect this data and enables these researchers to work together and collaboratively by sharing data across these sites. In a traditional setting, you'd have to actually have agreements, between one site with another site and that site with another site. You have these multi-party agreements, very complex. They can take years, and sometimes they don't even get done because it's so difficult sometimes to share these data. But with this approach, we have what you call the hub and spoke model, right? You have the wheel with all the spokes, and in the middle you have the hub, which is BrainCode. It enables all that data to come to one place. We worry about those agreements. We help make sure that we have all the governance pieces in place, that all the privacy is taken care of, the ethics are in place, and we enable that sharing across the sites. On top of that, BrainCode is also designed to enable data sharing for secondary use. And for example, everybody here today may want to access some data for secondary use. Now, BrainCode is a great platform. There is actually some public data on BrainCode that you could access today, like right now, within minutes. We also have controlled access data. So that's more data related to patients and participants. That takes a little bit longer. In our case, it usually takes about 2 weeks. So probably not recommended for this course. But there's a lot of rich data on BrainCode, but I'll mention many others in a few slides. So just a snapshot of the BrainCode platform right now. This is on the portal. You'll find this information. It's sort of a snapshot of the data that have been collected across these different research studies, and how much data exists per modality as well, and kind of the regions around Canada where these data have been collected at. The platform has also, I mentioned this ability for sharing. I mentioned also a little bit the common data elements. So we're collecting common assessments across each of these studies. So whether you're a patient in epilepsy or in neurodevelopmental disorder like ADHD, or maybe looking at major depressive disorder for mental health, there are common assessments or measures that are being collected around quality of life, medical history, demographics. We also collect common elements around depression, anxiety, and sleep. So those are all core elements that can then help sort of look at, how do you compare these patients and these participants across studies? Because in many cases, you may have some comorbid conditions, as I mentioned earlier, where there's overlap and you have more than one sort of diagnosis. And it's often the case, in fact. So a bit of a snapshot of this is the data that's actually available for secondary use and on the platform right now. So for the PON program in neurodevelopment, we have clinical and imaging data. For the CPNet program in cerebral palsy, we have clinical imaging molecular. We have genomics as well. We have whole genome sequences, and that should be added here. From EPLink, we have quite a bit of clinical data available, and we have a new data set that's going to come out soon that includes imaging and molecular. We have the Cambine data set in depression that has clinical imaging molecular, very rich. Also looking at an intervention from the use of escitalopram as a medication. We have the Connect program, a former concussion program that has quite a bit of clinical data, and the Andre program in neurodegeneration that looked at 5 major platforms in neurodegeneration across 520 participants. Very rich, very robust data quality measures and data collection for this study. That's all available on BrainCode. And I want to introduce you a little bit to this, give you a bit of a sneak peek of some of the things that we're working on next. Right now, when you request for access to data on BrainCode, you're accessing data from a single study. And that's great. You can select, the types of assessment that you want from that study. You can select maybe the types of modalities if you only want the imaging data or maybe the clinical data or both. But what's difficult right now is to actually create a cohort of interest that spans more than one study. If you want to collect data that cuts across mental, major depressive disorder with maybe neurodegeneration, you can't do that right now on BrainCode. And actually, you can't do that on almost every platform in the world. And so we've done a big landscape analysis to evaluate what exists out there, and nobody has really built something that's as robust as this. There are a few groups that have looked at more on the clinical side, on clinical data sets, like HDR UK, that have started to implement things like this. But in the research world, this is pretty rare. So what we've built here is a cohort discovery tool that allows you to search across studies. And so instead of looking by major brain disorder area, you're actually looking based on characteristics of the participant population. So are you interested in groups that have a certain age, that have a certain demographics characteristics? Have they completed certain assessments? Do they have neuroimaging data? Do they also have genomics data? And essentially it helps you cut across multiple studies and form a larger cohort that is constituted from data from each of these studies. So this is a quick snapshot. We haven't released this yet, but we will be later on this year. And so it's a bit of a sneak preview. On the left is sort of that traditional study view where you select first the major studies that you're interested in, and you add them to your cohort list. And on the right, you start filtering down, and all these graphs get sort of automatically generated to give you a snapshot of what is available from this data set. And if you're happy with this cohort that you've composed, you essentially make a request for access. So we're pretty excited about this. We're also looking for a lot of user feedback. So I'm hoping maybe by next year or next summer, we'll definitely, or maybe BrainHack in the fall, we'll have a version of this that everybody can test and use. And we'd love to hear back from users as to how well this works. Now, I'll also speak a little bit about the Center for Analytics, which is a new initiative at the Ontario Brain Institute, which I'm spearheading. It's really about building on top of what we've done so far in terms of data collection, enabling data sharing, but we want to enable everybody in the neuroscience space to really build the skills around neuroanalytics. And so helping develop those skills is essential. And this course is a perfect example of just that. How do we build skills around neuroanalytics so that we can better understand how do we use the multitudes of data that are available? How do we, what are the right models and algorithms that we can use to better decipher and understand these conditions? We want to really carve them at their joints, right? So we need to develop the right tools, the right algorithms to not only transform the data so that we can sort of bring them together and analyze them together, but we need to also potentially work on new algorithms, new tools and techniques that aren't quite there yet. And so this is the perfect setting. You learn about new techniques, learn about data, and start to really forge ahead with developing new methods to look at data that haven't been looked at otherwise. So developing skills is really important for us, and so we support events like this, but also brain hackathons, data challenges, other schools that develop training and asynchronous training opportunities. We also have a large emphasis around compute. Can we provide more compute that's effective for analytics? We know today, like for modern machine learning or modern high performance computing, we need access to those compute environments. And so we make these available through our cloud environments, such as GPUs and other types of compute instances that can help with research and analytics. And ultimately, we want to help labs and startups translate their discoveries, translate their findings. So everything you develop here today and over the next few weeks, you're going to learn about these new techniques, but these could potentially be transformed into real, tangible tools that can be used in a lab, that could be used even maybe commercially. Like if you feel that it's something that could be spun out into a unique technology that could really scale up and have an impact across multiple clinics or multiple labs around the world, then there's a potential opportunity to translate this into a tool that has impact at the international level, which you could either commercialize or at least make available even as an open source tool set. So how do we help organizations get to that point is part of what we do. Okay, so it's about a little bit of the background from what we do at the Brain Institute, and I want to jump into data sets. And so this is totally meant to be organic. I feel like I'm giving a bit of a lecture right now, but I want anybody to jump in and give feedback, and you may have other ideas on data sets that you think the group could benefit from. So I'm just going to start with a list here, and at the end I have a link, and there's a document that you can make recommendations on, and we can add them to the list. So I, added BrainCode at the top just because that's what I was talking about earlier. The C1P is the Canadian Open Neuroscience Platform portal. They also have a number of data sets that could be of interest. You guys can take snapshots with your phone, but I'll have a QR code at the end with a list of everything. So you might want to wait a few slides. I just want to give you kind of a bit of a teaser here so you get a sense for what might be available. But yeah, we have the Open Neural platform that's public, a lot of imaging data, almost immediately available, so very convenient. The Dandy archive, ADNI for Alzheimer's disease, the ABCD study, although with Aaron, we were just talking about how some of these US-based databases currently have been kind of locked down and might be hard to access. So you can always check out the links and see, but I think it might be a little challenging. Like the ABCD is based in the US. Nightingale might be available. The NIH data sharing repositories might be difficult. GAIN is international, so you should find some there if you're interested in neurodegeneration. Some more databases. There's a Wikipedia entry that's kind of interesting with a list of databases that are available. So that's a bit higher level. This is open source brain. The Lion 5B, the multimodal data set that's used in AI for like training these. It's a bit like a foundational model. It's kind of interesting, worth checking out. AWS from Amazon have a pretty rich open data repository, Microsoft as well, Google as well. The NeoGADS neurodegeneration dataset is, I think, a recent entry I've added here. A lot of interesting clinical data as well. The MIMIC dataset is one of the most popular datasets for clinical data, and it's available, I think, almost immediately if you look at requesting for access. Some clinical imaging data from SegMed AI. The Mayo Clinic has a platform here as well. TD Brain. We have PhysioNet. PhysioNet's a broader platform. There's lots of different data sets on PhysioNet. I actually think Mimic points to a PhysioNet archive. Voice data. There's a lot of work happening now in voice, a lot of interest in using voice as a potential marker for brain disease. We have a famous startup here called Winterlight Labs that came out of the GTA. That was probably one of the pioneers in using voice to detect the early onset of dementia. Very cool stuff. They've collaborated with a lot of researchers here in the GTA ecosystem and are doing a lot of great work. There's now other groups looking at this for how to use voice for other brain disorders. Can you actually detect it? Because there are specific features, right, in voice patterns. And talk about a great way to potentially diagnose, because you can get on the phone with somebody, you can administer this in multiple different ways, or even be on their chat app. But having a voice recording can be something that you can use readily in many different contexts. And if that can be used to help with in the clinical setting to better diagnose and treat, it could go a long way. So a lot of excitement in using voice. Some other good data sets so Bridge to AI, a large US-based platform. I'm not sure how difficult it might be to get that data. They're somewhat international. There's groups outside of the US, so maybe those data sets might be available, but definitely worth checking out. The Dementia Bank, Aphasia Bank, also rich repositories for voice data that were recently added. Pediatric MRI data that are available. Insight Eye for more eye-based data from the UK. The Reddit Suicide Watch and Mental Health collection on Zenodo. Open MEG archive called Omega from the McGill Group. Prevent AD, also from the McGill Group, is Alzheimer's data that's available. I think that might take a bit of time, so always a word of caution, like look at them, but right away what you want to do is look at how much time it might take for you to gain access to these, because yeah, it might not make sense in the context of the course. CamCan brain aging data sets. And I think, so, oh, sorry, it's taking time to load. Let's go. Okay, yeah, the other thing I want to highlight was, sorry, which slide are we on? Yeah, synthetic data, okay. Was I off by a slide? I think it might have been. No, now it's good. Yeah, so synthetic data. Another thing to consider, if you don't have the data that you need, you can also think about generating your own. And so there are really advanced tools now for generating synthetic data, especially for tabular type data. All of these are like readily available, especially like some of these are commercial. So, but you'll have like a sort of free version or a version that will be free for like a few weeks. SDV is actually completely open source. Synica actually have data sets that are synthetic, as well as the medical synthetic data and models from Hugging Face. So it's also an opportunity to look at. And I think actually the BrainHack that we had at SOBP, one group generated some synthetic data because they couldn't find the actual data set that they needed for the project. So always something to consider. And there's some tools in R as well, SynthPop and SimPop, that could be of value. Some also really cool models. This is just touching the surface. There's quite a bit here, but Hugging Face has a really cool Hugging Face for health models that's available as open source on their platform. So Hugging Face is known for being kind of an open source platform for a lot of machine learning models, and it's really a growing ecosystem, a bit like your GitHub, but for AI. And then a nice tools catalog that we've compiled at the Ontario Brain Institute for neuroscience tools. So that's it with a long list of links. Like I promised, a QR code to all these, and it's a Word. Sorry, it's a Google Doc. And right now, if you have any recommendations, if there's anything else here that you think should either be changed or added, you can add a comment. It's not like completely open to edit, but you can add a comment and I'll curate it later and add to it. But everybody else should be able to see your comments. So if you want to add things to it, feel free. And did everybody get a chance? I guess we could share this through the Slack, or I'm not sure what you're using for the course, but yeah. Just to kind of whet your appetite a little bit on what other groups have done, research groups with this type of data. So, multimodal data analysis. The group from Cambine looked at a major depressive disorder. They used this data to essentially try to predict the response to escitalopram. And they found that by combining the clinical and the molecular data, they were more accurate in predicting response to the drug than any one modality alone. So the combined, multimodal analysis was beneficial. So it's a good case for that argument. The PON group looked at neurodevelopmental disorders. They were looking at how do you actually reclassify standard labeling for neurodevelopmental disorders. So, between ASD, so autism spectrum disorder, OCD, and ADHD, we typically have, typical clinical labels based on the clinician's diagnosis of the individual. But they're a lot more complex than that. And it's not always clear sometimes that they fall into like these nice clear buckets or these nice clear categories. So what this group has done is use clustering algorithms, which are essentially non-supervised learning algorithms to look for features within the data and regroup these participants, and found that the participants sometimes regroup together in a different way than their clinical labels. And so this has actually inspired them to really drive the research in this area forward. And there's a lot more that they've done. This is a publication from a few years ago, and they're doing a lot more work in this area using different techniques and finding that it is a spectrum, literally, right, across these disorders. They're not cleanly cut. So very interesting work there that could be of inspiration. And there's a lot of other research underway. Clinical trials optimization is really interesting. Predicting outcomes is really important. Comorbidity disambiguation, we mentioned earlier, a lot of these brain disorders are complex. And so you present with different symptoms, different maybe typical diagnostic categories, but we need to disambiguate them. We need to understand really the fundamental mechanisms that drive these, that are at the source, or that are causing these conditions. So a lot of opportunities by leveraging multimodal data. And yeah, so this is just a highlight. How do we prevent health conditions? How do we detect the conditions up front? How can we predict the condition over time and their progression over time? How do we treat these conditions? And are we even efficient in handling health conditions, like when you think of the health system writ large? And ultimately, what are the good tools that we can develop to help support all of these questions that we have above? And so I think that's it. I'll stop there. Thanks, everybody. So in terms of, I don't know if you want to chat more about the data, like how to access data. Or...
Yeah. Okay. I thought. All right. Any questions directly for Brandon? We might come back to. So
yeah,
we wanted to state. Wait, I feel. Okay.
Use the microphone. Yeah.
Use the microphone. Okay. We wanted to remember because there were a couple guidelines for especially data or data choices for your projects that we wanted to make clear. Ryan, you remember them better, so you have to remind me. Okay, so one is you can bring data from your own lab, but one, you have ethics to share with your teammates, or two, and we'll look at the caveat, or two, know that you have permission of your supervisor to share, and that it's not going to get awkward authorship wise if you go off and write your thesis on it and your teammates are left in the dark. Back to ethics to share. So Francis gave us an amazing alternative or exciting option, is to use synthetic data generators for parts of your data, to build synthetic data out of data that exists in your lab that you want to look at, and then your teammates can help you build code to work with that data without you having to look into the ethics of being able to share it more broadly with people from outside your institution, which is also kind of a fun thing because you get to learn new synthetic data making tools and learn how to work with the data at the same time. So that's a cool option. So that was one about using data, sharing data. We also wanted to give a small disclaimer about talk to us about your data sets and how pre-processed they are at the moment. If you want to do something really cool, like a really cool model, you're probably going to need data that's already pre-processed. If you want to learn how to do pre-processing, that is totally cool too, but let's start early, learn early, because some of these pre-processing pipelines do need to run overnight, and if you need to resend them, 10 in-person days goes by really, really fast. So, and some of these pre-processing potentially take some of these pre-processing pipelines can take multiple days to actually troubleshoot and run. So they can eat up a lot of your project time. Also think about, because you're working in teams, think about things that there's lots of different things that people can work on within your project. So think about how you can break up tasks. Yes, those were, did I forget something that we also said we wanted to mention about data?
Could you show hands of who's bringing their own data?
Yeah, is anyone thinking of bringing their own data to the school? Well, do you want to say a little bit about what the data is? Oh, cool. Oh, nice. Cool. Oh, okay. Cool. Nice. Cool. Um, maybe, okay, do we have, maybe, I don't know if we want to do kind of a show of hands, data modalities wise. So just to see how we're doing in the room. Yeah?
I just wanted to mention one thing. Just be also mindful of your storage capacities on your computers. I know in the in the modules page, we recommend 40 gigabytes, but that's really just for everything you need to download today. But just be mindful of the number of participants you're bringing in and your compute capacity on your computer, because as Aaron said, with pre-processing, for example, it takes a lot of compute. So just something to be mindful of when you're thinking of your projects.
And I think some of us have compute capacity options kind of outside of this group. We can speak about trying to open up some others, whether they be cloud, whether they be cloud or whether they be some like compute alliance, Digital Research Alliance of Canada now, compute resources, but we'll figure those out based on needs. Yeah. Oh, that'd be cool. Okay. What else was I was gonna say? Okay, so who's thinking of doing like an EEG based project? Show of hands. Exciting. Who's thinking about MRI? Ooh. And of MRI, are we thinking structural MRI, anatomy? Some hands were functional MRI. Yeah, functional MRI. Represent. What about diffusion MRI? No love for diffusion. You gotta love your white matter microstructure. It's nuts. No water movement. Any other MRI modalities? People aren't okay. Within functional MRI, who has like cognitive task fitting thoughts in the context of a task? Oh, everybody's doing connectivity based? Or what kind of functional? There's like no hands. Oh, did I confuse people? Okay. We'll get there. Do people not know what kind of functional MRI you're doing?
fMRI 101.
Yeah, okay. What other data modalities are, what about MEG? Is anybody working with MEG? Minute Rose is putting up her hand. What about FNIRS? Anybody got some FNIRS love? FNIRS love?
Near infrared.
Near infrared fun? Did we get everybody? Did everybody put up their hands? No. Undecided?
Undecided.
You got,
Two.
are we undecided? We are undecided. Okay.
Anybody on the genetics molecular side?
Oh.
Yeah.
Ooh.
Cool. Cool.
Yeah. Yeah. For sure. I don't, yeah. Oh, what about pet? Any love for pet? Okay.
Does everybody know like what tools to use for the type of data they want to analyze, or are there questions around like tooling, like software, like platforms? Is everybody pretty comfortable?
No, we're in week one, day one.
Okay.
Okay.
Be,
We're gonna learn so much, guys.
That's awesome.
It's gonna be so great.
That's good.
Okay.
Okay. So I think I'm am I done?
Yes. Okay. Yeah, so Ryan did post the link to the data to the Discord. Everyone's on the Discord? Awesome. Okay. It's lunch break. Also, does anybody have recommendations? IKEA. Oh yeah, IKEA. Veggie meatballs with kimchi. Just so good, actually. It's very fresh. It's very good. Yeah. Wait, okay, before everyone leaves, no, come forward. We'll figure this out. So, people who are working with R or planning to use R, Ryan is going to teach like an ad hoc R module. We're trying to just on Thursday at some point. Which time works for most people? Probably on Thursday morning.
That'll deploy.
Well, okay, we'll announce it.
If
Probably Thursday morning.
unless there's it'll like noise like that. There's no
Yeah.
like speakers.
There's no, I don't think
Okay.
there's any other stuff. So probably, yeah, we'll announce ad hoc everything.
Can I also just get a quick like show of hands R wise, like if you can categorize yourself into three things, so novice, intermediate, advanced. How do you feel in terms of R the language? So novice, can I get a hand up? Okay. Intermediate. Okay, advanced. Okay. Thank you.